Hey guys, Mr. Backward here. In this video we're going to look at interest compounded K times per year. Now if we've got a principal amount invested in an account that compounds multiple times per year, we're going to have to use a little bit of a different formula than we've used before. So in order to calculate the amount of money in our account, then what we're going to do is take our principal amount, P, times 1 plus R over K, where R is the interest rate as a decimal, and K is the number of compoundings per year. But then we're going to raise this to the power of K times T. And again, K is the number of compoundings per year, and T is the time length in years. Then what's going to happen in here is this R over K ends up giving us the interest rate per compounding period, and then this K times T gives us the total number of compoundings over our time span. So let's say we had $500 to invest, and we find an account that's going to pay us 9% interest, and it compounds monthly. And let's say we want to figure out how much our investment is going to be worth 5 years later. So then if we want to figure out the amount of money that we have in our account, what we're going to have to do is start with our principal amount, so that's our $500, times 1 plus the interest rate as a decimal, so that should be 0.09, over the number of compoundings per year. So if we're compounding monthly, well, there's 12 months in a year, so there would be 12 compoundings per year. Then for our power, we're going to take that 12 and we're going to multiply it by the 5 years. Now if I take all of this and type it into my calculator, I should get 782.84. So after 5 years, we have $782.84. So let's look at things a little bit differently this time around. Let's still use that $500 principal amount. Let's still use a 9% interest, and let's still say that we're compounding monthly. But instead of being given a time frame, let's say we want to figure out when our account reaches $3,000. We want to find how long that's going to take. So if I'm using my formula, what I would do is I would put the 3,000 on the left-hand side equals the 500 times 1 plus 0.09 over 12 raised to the power 12t. Now we're trying to solve for that t value. So what I would do first is I'm going to take this 500 and I'm going to divide it over to the other side. So we should get 6 equals, now I'm actually going to take this stuff inside of my parentheses and I'm going to type that into my calculator, and I should get 1.0075, and that's being raised to the power of 12t. Now we're trying to solve for t, and t is up as an exponent in this problem. So what I want to do is I want to remember the relationship between an exponential equation and a logarithmic equation. So I can take this and rewrite it in logarithmic form by making it log base 1.0075 of 6 equals that power 12t. Now depending on your calculator with this left-hand side, you might be able to type in this logarithm with this given base. Otherwise you might need to use one of your change of base formulas to help you evaluate what's going on the left-hand side. But when we type this into our calculator, we should get about 239.796 equals the 12t. And then if I want to get rid of the 12, I'll need to divide both sides by 12. And that should give me a t value of about 19.98. So it'll take us just short of 20 years for this $500 investment to get up to $3,000. Now I'm going to change things up on you one more time. Let's still deal with that $500 principal amount, but this time I'm not going to give you the interest rate. That's what we're going to be solving for. Let's say that this one gets compounded quarterly, and let's also say that our amount of money doubles after 10 years. So what I'm going to try to do is set up my formula based on the information that we've got. We know that we've got a principal amount of $500. We've got 1 plus an unknown interest rate over, now if this is going to be compounded quarterly, then there's going to be 4 compoundings per year. Now for my power, I'm going to take the 4 times the 10, since there's 10 years. But for the left-hand side, for that a value, we were told that our amount of money doubled. We started with $500, so if we double that, then we should have $1,000. Now we're trying to solve for this r value, and I'm going to use my calculator to help me out. So in my calculator, I have 2 equations typed in. For my y1, I have the right-hand side of my formula typed in, but I did take the 4 times 10 to get 40 as the exponent. And for the y2, I have that left-hand side, 1,000, typed in. Now I'm going to have to adjust my window, so I'm going to hit my window button. Now our x value that we're trying to find is an interest rate, and we should recognize that typically when we're dealing with interest rates, they're little small decimal values. So I'm going to make my x min start at 0, and I'm going to make my x max just go up to 1, since we're dealing with a small decimal value. Now for my y max, I just typed in an equation that goes up to 1,000, so I need to go above 1,000, so maybe we go 1,250. Now when I hit graph, we'll end up getting a picture that looks something like this. I want to figure out where these two graphs are going to intersect, so I'm going to hit second trace, and I'm going to pick option number 5, intersect. I make sure that my cursor is on my first curve, which is my blue graph. I hit enter. I make sure that it switches over to the red graph, then I hit enter, enter, and we get an x value of 0.0699. Now if we wanted to convert that into a percent, we would have to slide the decimal 2 places to the right, so that would be 6.99%. That's going to be it for this video. Thanks for watching.